Hi, welcome to Ready Classroom Lesson 33, Session 3. Today we're going to be using a graph to compare patterns. So up until now, we've done corresponding terms. We've worked with corresponding terms, we've worked with tables, we've worked with looking for rules and patterns, and all of it has been kind of leading up to this, to where we're going to take everything that we've learned and we're now going to put it together and make a pattern, or put those patterns into a graph to see what the patterns look like in a graph. And so we're going to be working in our Ready Classroom math workbook on pages 691 through 696. So go ahead and turn to page 691 in your Ready Classroom math workbook now. Okay, so on this page it says this: read and solve the problem below. The Scouts are making model vehicles. They have a choice to make a model plane or a model boat. The materials for each plane cost $2. The materials for each boat cost $4. Write two patterns to show the cost for making 0 to 4 of each type of vehicle. Graph points in the coordinate plane to show a relationship between corresponding terms of the patterns. So that's kind of a lot. So first, what I want to do is I want to figure out, how do we want to do this graph here? And I'm going to do the graph a little bit differently than the graph that we're going to see on the next page, because I want you to see two different types of ways that this same data could be graphed. So I'm going to go ahead and down here on the bottom, I'm going to have this be the number of vehicles that we buy. So either the numbers of boats or planes. So we're going to call this the number of boats or planes. Because since we're going to be looking at how they look together, we will always have the same, we'll always be comparing the same number of boats to the same number of planes. So one boat and one plane, two boats, two planes, and so on and so forth. Then on this side of the graph, we're going to graph how much they cost. Now, the red is going to be the planes. And then I'm going to graph in blue the boats. Okay, so that we can put both on the same graph. So this is what we have here. So we're going, I don't think we need to do the number to begin with. We're gonna wing it, and I think we'll be okay. So let's go ahead and start with our number of planes. Now we know that each plane costs $2. So if we had 0 planes, how much would that cost us? That's right, 0 planes would cost us $0. Now, one plane, there's no 1 listed, but I know that 1 is between 0 and 2. So one plane costs $2. 2 planes would be $4. 3 planes would be $6. 4 planes would be $8. 5 planes would be $10. 6 would be $12. And we're going to keep going. I actually went a little too far. We didn't need to go that high, but I wanted to do it because I think it's cool to see how they both are different. So if we connected each of these dots, this shows us the number of the planes. Now we're going to go ahead and graph the boats. So when we graph the boats, if we have 0 boats, it also costs $0. Remember, the boats cost $4, and I'll just underline that because I think that I love making things color coded. All right, so if we had 1 boat, it would be $4. 2 boats would be $8. 3 boats, 3 boats would be $12. 4 boats would be $16, and that's probably why we had to stop there with the boats, because we don't have any more numbers. So if we connected all of the line here, and these are our boats. So now you can see that we have two patterns. We have our planes and we have our boats. And if we look each time, I'm just making sure I did it right. Oh, yes, I did. Okay. So now we can see that if we bought two boats, if we bought one boat and one plane, the boats would cost $2, the planes would cost $4. If the planes cost $4, the boats cost $8. If the planes cost, $6, the boats cost $12. And if the planes cost $8, the boats cost $16. So we're going to go ahead on the next page and kind of look at how those two go together, or how they are related. Go ahead and turn the page to page 692. So on page 692, they went ahead and helped us make a graph. We actually did this on the last page, and the information we graphed is all of this right here. When we spent $2 on planes, we spent $4 on boats. $4 on planes, $8 on boats. $6 on planes, $12 on boats. $8 on planes, $16 on boats. Personally, I think it's a little bit easier to look at it in a table than it is to look at it on the graph. But the graph sure looks cool, so there's nothing wrong with drawing a nice little pretty graph every now and then. Now, you can use this table to list the terms. And what's cool is that each of these terms creates an ordered pair. So if we had 0 and 0, our ordered pair would be 0, 0. If we had 2 and 4, we could put a dot at 2, 4. And this would, instead of on this graph, instead of doing it like we did, where we put the boats and the planes here and the cost here, they're comparing the cost of the planes to the cost of the boats. So when a plane costs $2, a boat costs $4. When a plane costs $4, a boat costs $8. And we're going to actually continue that in just a moment. So this is just a different way to graph it, and it gives the same information, but maybe it might make a little bit more sense to graph it this way to you. So if we're looking at the table in Model It up here, if we're looking at the table, what does the ordered pair 4, 8 represent? So they want us to look at this ordered pair, or this ordered pair, and what does it represent? What does the 4 mean, and what does the 8 mean? So the x-coordinate, which is 4, shows the cost of building 2 planes, which is $4. The y-coordinate, which is the blue, and that's 8, shows the cost of building 2 boats, which would be $8. So when you buy 2 planes, it is $4, and you buy 2 boats, it's $8. So how do these corresponding terms compare? So what do we know? That this number is this many times greater than this number, or this number is how much of this number? We could say that the cost of a boat is 2 times the cost of the plane, because 4 times 2 is 8. This is true for all the corresponding terms. If you multiply the x value by 2, you're going to get the y value. Number 3, the first 2 ordered pairs in the table are graphed on the coordinate plane. So they did 0, 0 for us, and they did 2, 4 for us. We're going to go ahead and plot the other 3 on the graph now. So we need to do 4, 8. So when the x value is 4, the y value is 8. When the x value is 6, the y value is 12. And when the x value is 8, the y value is 16. So again, this one looks a little bit different than ours, but remember, we're comparing the cost of the plane to the cost of the boats. It's a little bit different than what we did. Now, they want us to connect the points on the graph in the second model and explain what we see. So if we connect all of these dots, and I'm not doing a very good job connecting them, what do we see? If we connect the points, they make a straight line. Mine isn't exactly perfect, but it's okay. It's straight enough. Now, decide how to move along grid lines from one point to the next on your graph. So if I wanted to get from here to here using the grid lines, how could I do that? Well, I could move 2 units over and 4 units up. 2 units over, 4 units up. 2 units over, 4 units up. So we would move 2 units to the right and then up 4 units. The rule for the first pattern is add 2. So that means we would move 2 units to the right. The rule for the second pattern, which is the y value, is add 4. So we're going to move up on the y-axis by 4. So we could use these ordered pairs to show us how we would move. So with the rule add 2, we're adding 2 to the x value, and we're moving up to add 4 to the y value. So it's kind of cool that you could use those rules to actually move on the graph. Now, what is the strategy you like best when you are graphing to show the relationships between corresponding terms and patterns? Do you like to just do the graph like we did here, or did that kind of stress you out because you weren't really sure what we were going to be moving to next? Did you prefer to have a table and then to graph the points from the table? What is the strategy that you like best? Go ahead and write that down here and then tell me why. You can pause the video to finish working, and then when you're done, we're going to go to page 694. All right, on page 694, it says, consider the 2 patterns below. Pattern A is add 1, pattern B is add 3. Write the first 5 ordered pairs. Write 5 ordered pairs made up of corresponding terms from the 2 patterns. Plot the points in the coordinate plane to the right. Describe the relationship between the 2 patterns. Show your work. So, first of all, let's go ahead and fill out pattern A and pattern B. So, pattern A, we add 1. So, if we start at 0 and we add 1, we're going to move to 1. If we add 1 again, we'll go to 2. We add 1 again, we go to 3. We add 1 again, we go to 4. Each time we move over, we add 1 for pattern A. For pattern B, we're going to add 3. So 0 plus 3 is 3. Add 3, we get to 6. Add 3, we get to 9. Add 3, we get to 12. Now, we're going to look at each of these corresponding terms, and we're going to make these our ordered pairs. Pattern A is going to be our x value, and pattern B is going to be our y value. So if we do the ordered pair 1, 3, we're going to go to 1 on the x value and 3 on the y. And I forgot to do 0, 0, but that's where 0, 0 would have been. Okay. Now we need to go x is 2, y is 6. X is 2, y is 6. X is 3, y is 9. X is 4, y is 12. And as you can see, we graphed our pattern in a straight line because we had corresponding terms that had that all had the same patterns. All right, so if we look at pattern A and pattern B, what do we notice? How much more is pattern B than pattern A? What do you multiply pattern A by to get pattern B? That's right. pattern B is 3 times more than pattern A. We could also say pattern A is 1/3 of pattern B, because if you divided 3 by 3, you would get 1. So pattern A is 1/3 of pattern B. All right. In the school store, pencils are sold in packages of 6. Write 5 ordered pairs made up of corresponding terms of these two patterns based on selling 0 to 4 packages of pencils. So pattern A is the number of packages sold, and pattern B is the number of pencils sold. So we need to make sure we understand that pencils are sold in packages of 6 pencils. So if we have one package, it would be how many pencils? That's right, it would be 6. So we're going to go ahead and plot the points on the coordinate plane, and then we'll just see what we see as soon as we're done. So if we have 0 packages of pencils, we have 0 pencils. If we have 1 package of pencils, we have 6 pencils because we add 6 each time we move up. If we had 2 packages, it would be 12 pencils. If we had 3 packages, it would be 18. And 4 packages, it would be 24. So each time we move up with another package of pencils, we add 6 more pencils to the term before. Now, what is the relationship between the number of packages to the number of pencils? What is the relationship? Oh, we forgot to do our, I jumped the gun. Let's go ahead and plot our ordered pairs. So we have 0, 0, 1, 6, 2, 12, 3, 18, 4, 24. Now, describe the relationship between the coordinates of the ordered pairs. So these ordered pairs all have, well, I'm going to look because I'm trying to see what they want us to say there. Oh, that's easy enough. They just want us to say that, they want us to say that pattern B, which is the pencils, this is pattern A and pattern B. Pattern B is 6 times more than pattern A. Or you could say pattern A is 1/6 of pattern B. And then finally on number 9, Madeline and Javier graphed ordered pairs using the terms from the patterns they made. Madeline made the number pattern 0, 1, 3, 5, 7, 9. Javier made the number pattern with terms that were 3 times the corresponding terms in Madeline's pattern. Which list shows the ordered pairs for Madeline and Javier that Madeline and Javier graphed? So we know that Madeline had 0, 1, 5, 7, and 9. And so Madeline's is our X value. And Javier is our Y value. And Javier has 3 times whatever Madeline graphed. So what is 3 times more than 0? That's right, it's 0. What is 3 times more than 1? 3. 3 times more than 5? 15. 3 times more than 7? 21. And 3 times more than 9? 27. So if you look down below, which letter, A, B, C, or D, shows us these ordered pairs? 0, 0, 1, 3, 5, 15, 7, 21, and 9, 27. That's right, it is letter A. With that, you're going to go ahead and do pages 695 and 696 on your own. And if you have any questions, you can email your teacher. Otherwise, I'll see you tomorrow for our very last lesson in our Ready Classroom math workbook in 5th grade. We have arrived. We've made it. See you tomorrow.